So far, we have been working with probability, right? We've been doing a lot of work with probability. And in particular, we've been working with these things called discrete probability distributions, where we have the chart that shows all the probabilities of things. And these things were called discrete because they describe numbers that can be expressed using counting numbers, right? Like 0, 1, 2, 3, and 4. What we're moving now into is a brand new chapter where we're going to be dealing with continuous probability distributions. So numbers that can be expressed using fractions and decimals and things. And the problem with these distributions is they are a lot more complicated than the discrete ones. And finding the probabilities is way more hard than what we've been doing before. Okay. Before we go into a very specific continuous distribution called the normal curve, which we have done some work on, I'm going to throw some vocabulary at you. If I ever say a probability density curve, all I'm talking about is like a histogram, but with a smooth line instead of bars. Okay, so anything that looks like this, where it kind of looks like a histogram, but instead of writing bars, we just kind of put a line over it. That's what a probability density curve is, okay? And the biggest thing about these curves is if I shade in the entire area underneath the curve, that area is going to be equal to 1. Ouch. So kind of like the probability distribution charts where all the probabilities have to add up to 1. It's different with these guys because we're talking about the areas instead of adding up all the probabilities, okay? Now, whenever we talk about the area underneath a curve, for example, in this class, whenever we talk about this, it's going to represent the proportion of the population that is described using that area. And it also describes the probability of that area as well. Okay, so the idea of like a fraction or proportion is the same as probability in this section. Okay. Now, I'm going to talk about some properties of probability density curves. If this doesn't make any sense, we're going to be a little bit abstract. Let's just wait until we do an example because it'll make a lot more sense when we talk about this example, okay? But let's just go in the abstract right now. Let's just say I have a probability density curve. It looks like this, okay? What we're going to be doing is we're going to find the probability or the area underneath a curve in between like two x values. So we're going to be like figuring out what this area is, or if I choose two other spots, what's the area between those 2 points, okay? Now, things get a little bit more complicated if I don't choose 2 points. And for example, I want to find the area under the curve under just 1 point, okay? So I'm just trying to find the area of a single line on a graph, okay? Now, a single line doesn't have a width, right? The width of this line is going to be 0 because it doesn't have any width. I just drew a line, right? If area is like length times width, what do you think the area under something with a width of 0 is going to be? Just 0, right? So in this section, when we're talking about like the normal distribution, which we'll talk about later, whenever you want to find the exact probability of something or the probability under like one little point. So for example, the probability that x equals 5, okay, x is exactly 5, it doesn't really quite make sense to ask this question. So the answer is always going to be 0, okay? So whenever you're asked for a specific probability, like what's the probability that we have exactly 3 plants? It's just going to be 0, okay? All right. Next, let me take that a little bit further. Okay, if the probability of an exact number is going to be 0, then let me give you 2 probabilities that you might want to find. Let's say I want to find the probability that x is, I don't know, less than 7. Okay, and I also want to find the probability that x is less than or equal to 7. Okay, do you think there's going to be any difference in those probabilities? I see some nods, I see some shaking heads. It's actually not going to have any difference, okay? If an exact probability is equal to 0, then it actually means it doesn't matter if there's a less than or equal to sign. So in this section, it doesn't matter if it's less than or equal to, greater than or equal to. These probabilities are always going to be the same we don't care about less than versus less than or equal to in this section. It did matter in the previous section. It doesn't matter here. Okay. Finally, the total area underneath the curve always equals 1. Kind of like the sum of all the probabilities is 1. Same thing here. If I color everything underneath the curve, that's going to be 1. Okay. Now, that's really abstract. We might go back to this, but why don't we do a few examples first? We'll come back to this. This is really abstract, and it will make more sense a little bit later. Okay. So in this example, I have a probability density curve, and this represents the GPA of a bunch of graduating seniors at a university. These GPAs don't look too great. I mean, they're all right, but it's definitely like more to the left than to the right. Okay. So what we have here is we have a shaded area here, and that area is 0.67. We have a shaded area here, and it's 0.24, and then we have this other area that we don't know the area of. Okay. Letter A. Let's say I wanted to find the proportion of seniors whose GPA is between 3.0 and 3.5. Can someone tell me what that area would be? 0.24, right? Because it literally has an arrow pointing to between 3.0 and 3.5. It says that area is 0.24. That's the answer. So this question asked for the proportion of seniors. If it asked for the probability that we chose a senior between those two, it would be the same thing. Proportion and probability mean the same in this section. Okay, letter B. Think about what we did in the last page. If I wanted to find the area under the curve of exactly 2.5, what do you think that answer is going to be? I think I saw it. 0, right? Remember, in the last page, we said the probability of an exact number, like the probability that x equals 5 or is exactly 5, the answer to these questions is always going to be 0 for this section. So whenever you're asked like an equal to question, answer is always 0. That's it. Okay. Part C. This time I want to find the probability that a randomly chosen senior has a GPA greater than 3.5. Well, based on this graph, that looks like the area to the right where, well, we don't have an arrow pointing to it. Any ideas on how we would get this area? Elise? Yeah, perfect, right? Everything underneath the curve has to add up to 1. So if I add up these two numbers, I'll get everything here, which means all I need to do is, well, get everything else that's required to make everything equal to 1. And if that doesn't make sense, how I would do it is I would take 1, which is the total of what everything's supposed to add up to. I would subtract off this area that I already know, 0.24. And then I'd also subtract off the 0.67 because, well, I'm not interested in that either. And what I'm left with is 0.09, which has to be the remaining part that, well, I don't know the area. Okay. Any questions on how I found A, B, or C? Okay. Let's move on to example number 2. Now this example is a little bit different because instead of just one graph, I'm giving you the same graph, but I'm shading different areas of it. So this graph shows the area below 0.75, and this area shows the area below 0.85. I'm going to give you a few minutes to work on these. These questions are a little bit harder, but I think you'll be able to figure it out. So just because there's a lot to cover today. Okay, so here we have 2 graphs. They describe the same thing, but we just have different areas shaded. Let's work on part A. I think everyone was on the right track here. Okay. This one asks us the probability that Z is greater than 0.75, which means, well, we're probably looking at the first graph because, well, 0.75 is on there, right? Okay. I know a lot of you recognize that, okay, I know 0.7253 has to do with the answer, but 0.7253 represents the area to the left of 0.75, which is actually a less than area, right? This question is asking for greater than. So how did you get the answer to part A? Rylan?
I did 1 minus the area of everything to the left of 7.
Perfect. right? So 1 minus the 0.7253. And when you subtracted that together, you should have gotten 0.2747, I think. All right. So that should have been the answer to part B. All right, let's do part B. I think part B was the thing that tripped everyone up. This one's a little bit harder, and we'll be dealing with questions like this throughout the rest of this section. This one's a little tricky, okay? This time we want to find the probability of a between area, and we want to find the area between 0.75 and 0.85, which are the two values in each of the two graphs. So essentially what we're trying to find is, well, if I marked 0.75 on my graph and I marked 0.85, I'm really trying to find the area in between, okay? Any ideas on how I could get that area? Well, let's see. Oh, inch, yeah. Well, the probabilities for each, but perfect, right? So Andrew was like, okay, I know the probability of 0.85 is this, right? I know the probability of 0.75 is this. So what if I subtracted them? Does that kind of make sense? Is that what you're saying, Ange?
I would say
The actual numbers?
yeah.
Well, yeah, if you subtracted the actual numbers, you would get like the difference between the z values themselves, but we're actually asking about the probability. So what you have to do for these questions is you're essentially taking this whole area and you're like subtracting off this area off of it. So let's say I like just superimpose this graph on top of the right graph. It would kind of look like this, right? Okay, so I think if you kind of see them on top of each other, if you take the big graph and subtract off the small graph, well, you're left with what's in between, okay? So the whole idea on finding these in between probabilities is, well, if you want to find the area in between these two, take the big area, 0.9798, take the small area, 0.7253, and just subtract them from each other. Okay, so you should get 0.2545, and that's your answer for part B. If it doesn't make sense now, we'll be doing this a lot through the rest of this section. So just hang tight. We'll keep doing this. It'll make sense eventually, I promise. Okay, part C is the easiest one. If I want to find an exact probability, what's always the answer? 0. Perfect. Exact probabilities for this section is always going to be 0. All right, any questions before we move on? Okay. Before we start talking about finding these probabilities, I want to talk about some properties of the normal curve that we have gone over, but I feel like we've just forgotten because, well, it's been a while, okay? Remember, the normal curve looks like a bell. It has that bell shape. And a really special property of the bell curve is right in the middle, we have the mean. We also have the median and the mode. So all of these three numbers are smack in the middle of our bell curve, okay? Now, if I take our mean and I like bring it up to the top of the graph, imagine folding the graph in half around that line. It would be the same on the left and the right, right? So one thing about the normal distribution is it's very symmetric, right? The left half looks pretty much the same as the right half. And it's symmetric about the mean, which is mu, right? Number two, I literally just wrote it down, but the mean is always the same as the median, and the median is always the same as the mode here. So the normal distribution is very special because, well, it's very symmetric. The middle is all the important stuff. But if we kind of steer away from the middle, and let's just focus on the outer edges of this graph, okay? Now, the normal distribution, it kind of looks like it weans off to the left and the right. In this picture, the left-hand edge of this normal distribution, it looks like it touches the x-axis, but it actually doesn't, okay? This picture is just not very good. This graph, it gets really close to the x-axis, but it never touches it, okay? And it also does it on the other side, okay? This graph, Gets really, really, really close to the line, but it never touches that x-axis. Does anyone know what that property is called? It starts with an A. And asymptote, right? Whenever we talk about the idea of an asymptote, we're talking about a graph that gets really close to something like the x-axis, but it never touches it, just gets really, really, really close to it, okay? And the way that we talk about an asymptote is we say that the normal distribution is asymptotic to the x-axis. Okay, so we get close, but we never touch it. Okay. Now, let's just do some review based on what we've done before, but I feel like it's just been a while, so maybe we need a little review here. Whenever we talk about a score on the x-axis, like I don't know, any x value close to the mean, far away from the mean, we have been able to measure how high or low that score is based on how far it is either above or below the mean, right? Which, remember, the mean is mu, okay? So we were able to be like, okay, I know the score is somewhat high above the mean. I know the score is below the mean. And we were even able to be like really precise about that by talking about it in terms of the standard deviation, right? Remember, standard deviation uses that sigma symbol, okay? Now, I think we remember, okay, we were able to take a score and be like, oh, this is 3.5 standard deviations below the mean, or it's 0.6 standard deviations above the mean. Does anyone remember what that measurement was called? The z-score, right? The z-score told us how far above or below we are from the mean. And it made it really easy because it represented that in terms of the standard deviation. Does anyone remember the z-score formula? A fraction? Eric? Perfect. It was x minus mean over standard deviation. Okay. We'll get into that a little bit later, but for now, let's just kind of leave it at that. Okay. One other thing that you might have remembered about the normal distribution is we used the empirical rule, which told us the percentage of the data values within 1 standard deviation, 2 standard deviations, and 3 standard deviations of the mean, right? So we have those percentages, but what we're going to do is we're going to get a little bit more precise. We're not going to be restricted to just 1, 2, or 3 standard deviations away from the mean, and we'll be able to use Minitab to be able to do that. Okay, before we go into that, I want to talk about a very special distribution, which we call the standard normal distribution, okay? This is the bell curve, but it has a very specific mean and a very specific standard deviation. The mean is 0 and the standard deviation is 1, okay? Whenever we talk about the standard normal distribution, we're talking about the curve, the mean is 0, standard deviation of 1, okay? And really important thing about the standard normal distribution is z-scores actually follow it. So whenever we're talking about the z-score, we know that the mean of what we're talking about has to be 0 and the standard deviation of what we're talking about has to be 1, okay? So we'll talk about why that's important later. Let's flip the page. Okay. So might be wondering, how do I find probabilities using the normal distribution, right? Well, in the past, and I think some professors still use this, we had these charts of values before technology existed. We just had these charts and we had to use the charts to find different probabilities of things. I hate charts. Also, we're going to be using a lot of different charts later on in this class. And I like to limit our charts to like 2 charts. Okay, I don't like having more charts in this class than we need to. So what we're going to do is the only thing I'm required to teach in this class, and I'm going to tell you how to use Minitab to find probabilities using the normal distribution, okay? And this is how we do it, okay? First of all, you're going to follow a bunch of instructions of what to do on Minitab. You'll just click a bunch of stuff, okay? Then once we get to step 5, we have the option of 2 different instructions. If we're trying to find the probability dealing with an X value, we're going to deal with these 2 instructions. If we're given a z-score, we're going to follow these instructions. Okay, so 2 different instructions for different questions. All right, I honestly think it's so much easier to show you like what to click on Minitab if we deal with an actual example. So let's kind of skip this right now and let's go to example number 2. Okay. In example number 2, we're given a bunch of questions about z-scores. So we're not given like a situation where we have x values. We know that what we're dealing with is a z-score. Okay. So part A, we want to find the proportion of z-scores that are less than For part A, why don't we do something? I want you to X out this 0.68 and replace it with 0.75. I just wrote this question wrong and I put 2 different numbers in the same question. Okay, now that we adjusted the question, we want to find the proportion of z-scores that are less than 0.75. Okay, so basically find this probability. Before I even go about doing this, I love drawing pictures. I'm a very visual person. I don't like doing questions without actually like looking at what I'm actually doing here. So what I have here is I have a normal distribution, okay? And since we're dealing with a z-score, I'm gonna put in a mean of 0 and a standard deviation of 1, because remember, z-scores follow that standard normal distribution that has those specific values. Okay. If I want to find a z-score of 0.75, looking at my graph, 0.75 is about here. Doesn't have to be perfect, but it's about there. And once I plot my x value, I can kind of extend that line all the way up to the top of my graph, right? Okay. If I want to find the probability of less than 0.75, do you think I should shade the area to the left or to the right? To the left, right? Because left means less than, right means greater than. Okay, so I'm just going to shade in all the area to the left of 0.75. I want to find the area under the curve that's to the left. Okay, now that I have this visual in my head, I'm going to go ahead and actually follow the instructions for Minitab. Okay, and I actually want to show you what I'm doing here. All right, so, it looks like, I guess I'll do this. All right, let's go to Minitab. So if you just kind of look up to the instructions here, I'm just going to follow what it says. My session has expired. Oh, no. Okay, I might have to log in again. This is annoying. All right. Great time. All right, here we go. There we go. All right. So step 1, it says I want to click calc. So I'm going to do that. I'm going to click probability distributions. And then we've actually done this before. In the last section with binomial distributions, you click the probability density function. This time we're going to click the cumulative distribution function. So I'm going to click this guy here. Okay. Step 2, form of input says a single value. Looks like that's already there, so I'm not going to touch that. Step 3, under value. It says input the x value or z-score of the value you want to find the probability of. Looking at my question, I want to find the probability of less than 0.75. So I'm just going to put 0.75 in the value. All right, step 3 step 4 says distribution, normal. Don't have to touch it. Looks like I'm good there. Under step 5, I have 2 options, right? I have one set of instructions for an x value. I have another set of instructions for a z-score. Am I given an x value or a z-score here? Z-score, right? So when we deal with a z-score, remember it follows the standard normal distribution, which has a mean of 0, a standard deviation of 1. So I'm going to make sure it says that. I don't even have to change it because it's right there. All right, looks like we're done step 5. Step 6, output, display a table of cumulative probabilities. Looks like that's already selected. So I'm going to click OK. And what comes up is my probability, right? So this chart basically says the x value that I'm interested in. And then on the right, it gives me the probability of less than that x value. So that's what we have on our paper here. Any questions on what I typed in on Minitab? All right. So it's kind of annoying swapping back and forth on my iPad, but I still like using my iPad for class. All right. So basically, once I'm done doing that, I know what my probability is. It's literally right there. So my answer is 0.773373. That's the answer to the question. All right. Any questions on example number 2? All right. If you flip your page over, I have a couple more. Let's say I wanted to find the probability. Well, in part A, I found the probability of less than 0.75. What do you think the probability for less than or equal to 7.75 is? It's going to be the same, right? This was kind of a while ago, but on the first page, I told you that the probability of like less than 7, the probability of less than or equal to 7, it doesn't matter if it's less than or equal to. They're always going to be the same probabilities. So here, it's literally going to be the same answer as my last question. I'm literally just going to copy and paste it. So copy that answer. Let me just paste it on. That was easy. All right, part C. This one asked me for an exact probability. I want to find the probability that Z is equal to 0.75. What do you think that probability is going to be? 0, right? Whenever you're asked for an equal to probability in this section, the answer is always going to be 0. That's it. All right, not too bad so far. What we're going to do is let's skip D. If we have enough time, we'll go back to part D. Let's go to part E. Okay. Part E, this one's a little bit different because this time I want to find the probability of between, right? All right. So I'm still dealing with a z-score. Looks like we're dealing with a normal distribution with a mean of 0, standard deviation of 1. Let's just plot the area of what we're trying to find. So if my z-score is negative 1.38, that's got to be like around here. And 0.68's got to be like a little bit bigger than 0, so probably here. Okay. So I'm just going to extend these x values up to the top of my graph. And if I shade in the area, I'm shading in the in-between area. Okay. So what I'm actually interested in is the area between those two values. Okay. Let me show you what I would do on Minitab to find this probability. Now, on Minitab, there's really no like way you can just type in the two probabilities and tell it to find the probability of between. Minitab isn't that advanced yet. So what we're going to do is I'm just going to follow the same steps that I did for the first question and just do the same thing for negative 1.38 and 0.68. So I'm going to go to calc, probability, cumulative, just like I did before. I'm going to input everything the same, except I'm just going to change the numbers to negative 1.38 because that's one of the numbers I'm given. Everything else is the same. And I'll get my first probability that you see on the left. And then I'm going to click the same commands, probability, cumulative. And this time I'm going to put 0.68. Hit OK. And I get the probability that's on the right. Okay. So I basically just did the same instructions. I just put different numbers in with what I'm given in the question. Okay. Let me switch it over here. Okay, let me tell you what I just did there. Okay, I clicked through Minitab, and let me tell you what these actually mean. Okay, so when I found this probability, when I typed in negative 1.38 and found that probability, what I actually did here is Minitab's telling me everything underneath 1.38. That's what Minitab is trained to do. It doesn't do anything else. It's kind of dumb. Okay. When I type in 0.68 on Minitab, this is what it's doing. If 0.68 is here, Minitab's telling me the probability underneath 0.68. It's not doing anything else. It's literally doing the same thing I did for the first question. Okay, so I know what these two probabilities are for these specific graphs. Does anyone remember how to get the middle? It's kind of like what we did in example 2 with the two different graphs. Eric?
Subtract the 0.75 minus the 0.0.
Perfect, right? Because when we have two graphs and we want to find the middle, what you're going to do in every situation is you're going to take the larger probability and the smaller probability, and you just subtract them together. So for any in-between question, take my final answer, if I can spell answer, oh gosh, answer is taking the bigger probability, 0.751748, taking the smaller probability, the 0.0837933, and just subtracting them together. So when you subtract them together, we get 0.6679. That's the answer of the in-between probabilities. So you have to do a little bit more work to find this probability, because you can't just plug it in a Minitab and get the answer. You have to subtract it. Okay. Any questions on part E? All right. Let's flip our page over to part F. Let's say I want to find the probability that my z-score is greater than or equal to 0.35. Same thing. I'm given a z-score, so I know my mean is 0. I know that 0.35 as a z-score is, I don't know, probably around here. That's probably not that accurate, but it's close enough. Okay. I'm going to extend my x value up to the top of the graph. And since we're doing greater than, this is different because now I'm going to shade in the area to the right of the graph, right? Not to the left. Okay. Now, what I did is I went ahead on Minitab. I did the same thing. I followed the instructions. I found, I typed in 0.35 in the value field. I clicked OK. This is what Minitab gave me. Okay. Let me explain to you what that output is telling me. Minitab always tells us the same thing. This is telling me the area underneath 0.35. Okay, so what this is giving me is the area to the left. I'm not interested in the area to the left. I want to find the area to the right. So how do you think I'm going to get my final answer? 1 minus, right? So if you're trying to find a right area, Minitab gives you the area to the left. My answer is 1 minus the probability to the left. So 1 minus 0.636831. That gives me 0.3632. My final answer is 1 minus. Okay. Any questions for part F? Okay, so this seems kind of complicated, but really there's only like 4 types of questions you can be asked in this section. The first question you can be asked is an exact probability where the answer is always 0, right? The second question you can be asked is a less than question where you literally just type it into Minitab and that outputs your answer. You can be asked a between probability where you just subtract the 2 probabilities, or a greater than probability where you do 1 minus. Those are the only 4 questions you can be asked in this class. That's it. Any questions on how we do these questions? All right. Let me show you an example of doing these questions where we're not actually given a z-score, we're given an x value. And this is the type of question that you might be asked as well. Okay. So here we have a distribution. It's normally distributed. It has a mean of 20 and a standard deviation of 5. Okay. In part A, I want to find the probability that x is less than or equal to 22. Okay. This time, we're not given a z-score. We're given an actual x value, right? We're given an actual data value. So that means we're not actually following the standard normal distribution. The mean isn't 0. The mean is actually the mean given in the question. So in my graph, the mean isn't going to be 0. I'm going to cross that out and replace it with 20. Okay. And in my graph, each standard deviation isn't 1 anymore. The standard deviation is 5. So that means like if I go up 1 tick, it's got to be 25. And if I go up another tick, it's got to be 30. Okay. So that doesn't really matter. If I want to find the probability that x is less than or equal to 22 on my graph, well, it looks like 22 is going to be to the right of 20, my mean. So the x value that I'm interested in is this value here. Okay. Let's say I want to find the probability of less than or equal to 22. Looks like I have to shade into the left, right, instead of to the right. And let me show you what I type into Minitab this time. Okay, so I think you already know what I'm going to do here, but just in case, let me show you what I'm typing in. Okay, same thing as we normally do. We click on Calc, probability distributions, cumulative distribution, same thing as we've always done, okay? The form of input and everything stays the same. The value is the value in the question that you're trying to find the probability of less than, okay? So in our question, we're asked about 22. So 22 is what I'm typing in for the value, okay? Now, the only thing that changes when we're dealing with an X value instead of a Z-score is what we type in for the mean and the standard deviation. We're not dealing with a Z-score anymore. So it looks like the X value, it looks like the mean isn't going to be 0 anymore. The question tells us that the mean is 20, right? The question also tells us that the standard deviation is 5. So I'm going to change that standard deviation as well. Okay, so whenever you're asked about an X value, you also have to change what the mean and standard deviation is. All right, so just going to click OK. And the output is what's on your paper here, 0.655. Any questions on what I did on Minitab here? All right, so let me just share my screen again. Oh, there we go. Okay, this is what pops up on Minitab. Do I have to do anything with the 0.655? No, right? This is a less than or equal to question. This is our easiest question on Minitab. The answer is literally the Minitab output. So 0.6, oh gosh, 0.655422. That's my answer. Don't have to do. I know some of you are still working, but I don't want to end class late. So why don't we just go over these? Next class, we'll have more practice working on these and typing stuff in the Minitab as well. Okay, let's say I wanted to find the probability that X was between 19 and 21. Well, I know that the mean is still 20. So like 19 would probably be around here. 21's probably around here. So this question is really asking like a between probability, right? So what I did in part B is I went through Minitab, I typed in everything as I did in the first situation. I typed in 19 and got this probability, typed in 21, got the other one. How do we find between probabilities? Subtract them, right? So you're going to take the bigger number, the 0.579260. You're going to take the smaller probability, the 0.420740. And when you subtract them together, well, we get 0.1585. And that's the final answer. So whenever you find between probabilities, all you really have to do is subtract the two numbers. All right, let's move on to part C. This time we're trying to find the probability that X is greater than 23. If the mean is 20, I guess 23 is probably around here, bigger than 20, right? And well, I'm finding a greater than probability, which means I'm shading in the area to the right. Okay, so what I did here is I just went on Minitab, I typed in everything as I did before, and this probability came out here. Is that my final answer? What do I have to do to the 0.725? 1 minus, right? So whenever we have greater than questions, we always do 1 minus the probability, 25747. And when we subtract that from 1, we get 0.274. And that is our final answer. All right. Any questions on part C? Part D, I don't really know why I put this on here, but let's say this time we're not dealing with an X value. I want to find the probability that any Z-score is less than 0.2. This time we're dealing with a Z-score. So on Minitab, what am I writing as the mean? 0, right? And the standard deviation has to be 1. Okay, so whenever the question's asking about a Z-score, not an X value, this is what we're typing in for our mean and standard deviation, which means in our picture, well, the mean has to be 0. The standard deviation is 1. I don't have to change like anything in this picture. Okay. Well, based on my picture, the Z-score less than negative 0.2. Negative means we're below the mean. So I guess negative 0.2 has to be around here. Okay. And if I'm doing a less than score, I guess I'm shading in everything to the left, right? Okay. So I went through Minitab, I changed the mean standard deviation to 0 and 1. What's my final answer? just the 0.420, right? Literally what pops up on Minitab is my answer when it's a less than question. So you literally don't have to do anything for this question. The answer is literally up on Minitab. All right. Any questions on finding normal probabilities? Yeah. Oh, part B? Yep. All right. What we'll do on Wednesday is we are going to do a little bit more practice with these. I want you to practice actually typing stuff in on Minitab. We'll also talk about how to go backwards, but that's what we're doing on Friday. If I don't see you on Friday, I hope you have a great spring break.